All right, in Chapter 7 here, Unit 7, we're talking about factoring. And specifically, Section 1 here, we're going to be talking about the greatest common factor. Well, what does the factor mean? When we factor something, we're talking about making it a multiplication problem. And if I have 270, how am I going to make that into multiplication? Well, I'm going to find the prime factors. I prefer to find prime factors this way. What I'm going to do is I'm going to put a box underneath the 270. I'm going to start dividing by 2. 2 because it's the smallest prime number. So I take 270 divided by 2 and I get 135. Now, since it's odd now, I'm not going to be able to divide by 2 anymore. So I'm going to move on to 3, my next prime number. And I know that 135 is divisible by 3 because when I add the digits, I get 9. 1 plus 3 plus 5 is 9. So I can divide this by 3. It turns out that I get 45. I'm going to keep dividing by 3 until I can't divide by 3 anymore. And I end up with 5. So 270 is actually 2 times 3 times 3 times 3 times 5. And that's how I change it to a multiplication problem. There's your answer. Now in number 2, we have negative 900. And here's a little thing about negative numbers. When the number is negative, start with dividing it by negative 1. And that way I get rid of that negative and I can just start dividing by 2 and I get 450. I'm going to divide that by 2 and I get 225. 225 is divisible by 3. I know it ends in 5. We could go ahead and divide by 5, but I like doing it this way because by the time I'm done, I will have all of my prime factors in numerical order. So I have negative 1 times 2 times 2 times 3 times 3 times 5 times 5. Do you recall what 32 is, the prime factors? Well, it's 2 to the 5th power. So I'm going to write down 5 2's, 3 x's, and a y, and there are your prime factors for number 3. So how do we find the greatest common factor of two different numbers? Well, there's a couple of different ways to do this. The way I like to do this is to write out the prime factors of 12. What are they? 2 times 2 times 3. And if we were to find the prime factors of 48, we'd have 2 times 2 times 2 times 2 times 3. And what I'm going to do here to find the GCF is find all the factors that are in common. Well, I have a 2 in common. Write it down. I have another 2. Write it down. I don't have any more 2's, but I do have a 3. Write it down. The GCF, 2 times 2 is 4, times 3 is 12. 64 and 80. Can you think of what the GCF would be here? Well, a lot of people are going to be thinking 8. And 8 is a common factor, but let's see what happens when we find the prime factors of each. 64 is 2 times 2 times 2 times 2 times 2 times 2. 6 2's, 2 to the 6th power. 80, we're going to have 2 times 2 times 2 times 2 times 5. So now in finding the GCF, I find the factors that are in common, and I have a 2, I have another 2, yet another, and a 4th. And that's all I have in common. So 2 times 2 times 2 times 2 is 16. So 8 may be a common factor, but it's not the greatest common factor. Now, if you want to take a shortcut in finding the greatest common factor, you can try this. Take the smaller of the two numbers. Does it go into 45? Yes, it does. So 15 is your greatest common factor. We could have done this back here with number 1. Does 12 go into 48? Yes, it does. There's your greatest common factor. We could have done this with number 2. Here's what we would do is take 64. Obviously, that doesn't go into 80. So divide 64 by 2. 32. Does that go into 80? No, it doesn't. Divide it by 3. Well, 64 doesn't get divided by 3, so let's move on to 4. What's 64 divided by 4? 16. Does that go into 80? Yes, it does, so we could have done it that way as well. In number 4, 27 is equal to 3 times 3 times 3. 32, as we noted above, is 2 times 2 times 2 times 2 times 2. We don't have any numbers in common except for 1. So 1 would be the greatest common factor here. In number 5, 12a. Well, 12a, what are the prime factors? 2 times 2 times 3 times a. How about 18, a, b, c? Well, we have 2 times 3 times 3 times a times b times c. And what do we have in common? Well, we have a 2 in common. We have a 3 in common. And we have an a in common. That looks like that's about it. So our greatest common factor here would be 6a. 96y, 12x, and 8y. So let's see now. 96y is equal to 2 times 2 times 2 times 2 times 2. I think that's 5 2s, and times 3 times y. 12x is 2 times 2 times 3 times x. And 8y is 2 times 2 times 2 times y. And what do we have in common? Well, we have a 2. We have another 2. Now, it's got to be in common in all 3 terms. Do we have another 2 in all 3 terms? No, we do not. Do we have a 3 in common in all 3 terms? No, I have a 3 here and a 3 here, but not in the last term. Do I have an x in common? No. Do I have a y in common in all 3? No. So my greatest common factor here would just be 4. And in number 7, all right, you wanted to see the shortcut? Again, look at the coefficients. Does 4 go into 28? Yes, it does. So there's 4. And then how about this? How about we just go with the, as far as the variables are concerned, the smallest exponent? Because that's all we need to do. We have a squared and we have a, so a would be the greatest common factor. We have b to the first and b to the first. What's the smaller exponent? Well, b to the first. And there you have the greatest common factor for number 7. All right, now we have these 3 terms, 28y squared, 35xy, and 49x squared y, and we want to find the GCF. Now we could go through and find all of the prime factors, but let's see if we can do this another way. 28 is the smallest number. Obviously, 28 is not going to go into 35. How about taking 28 and divide it by 2? 28 divided by 2 is 14. Does that go into 35 and 49? No. 28 is not divisible by 3, so let's try dividing it by 4. 28 divided by 4 is 7. It goes into 35 and 49, so 7 would be your greatest common factor. Is there an x in common in all 3 terms? No, there's not, so x is not going to be involved. How about the y's? I have a y squared, a y, and a y, the smallest exponent, y to the first power, so the GCF is 7y. In number 9, we have 18 and 36. Does 18 go into 36? Of course it does. So we're going to have the GCF as being 18. And then I have a to the third and a squared. Which one has a smaller exponent? Obviously a squared. And then the smaller exponent for the b squared and b to the third would obviously be b squared. So 18, a squared, b squared is the GCF there. In number 10, 2, 9, and 18. Now, it's true that 2 times 9 is 18, but do they have a common factor here at all? No, 2 doesn't go into 9, so we don't have an actual coefficient that's going to be involved here. But I do have x squared, and x. So I have an x in common. I have y to the third, and y squared. I have a y in common. So the GCF here would just simply be xy. Well, good luck on this. Hope everything turned out all right. And if it doesn't, we'll talk to you about this more in class next time. Have a good day, and we'll see you then. Bye.